The iron. Iron is mentioned in Quran chapter 57. In fact, chapter 57 of the Quran is named Al-Hadid, the iron, and the only stable isotope of iron that exhibits magnetic properties is iron, 57. Iron has 4 naturally occurring stable isotopes: iron, 54, iron, 56, iron, 57, and iron, 58. A key characteristic that breaks down these isotopes is their magnetic property. Iron, 54, iron, 56, and iron, 58 are non-magnetic because they have no nuclear spin, which means they lack a magnetic moment. In contrast, iron, 57 is magnetic. This is because it has a nuclear spin of half, a property that gives it a magnetic moment and makes it useful in techniques such as Morse-Bauer spectroscopy for studying magnetic properties. The magnetic properties of iron are defined by 2 fundamentally different phenomena: the ferromagnetic moment and the nuclear magnetic dipole moment. The ferromagnetic moment originates from the spin of the electrons in the outer shell, specifically the unpaired electrons in the 3d orbital, and is a macroscopic effect. This is the dominant source of iron's powerful magnetism. When these electron spins align collectively across large regions called magnetic domains, they create a strong, measurable magnetic field, making iron a ferromagnetic material capable of forming permanent magnets. In sharp contrast, the nuclear magnetic dipole moment originates from the spin of the protons and neutrons within the nucleus, Fe57 being the most relevant isotope with a spin of 1/2. This effect is subatomic, approximately 1,000 to 100,000 times weaker than the electron moment, and does not contribute to the bulk magnet you feel. Instead, the nuclear moment is crucial for highly specialized analytical techniques, such as Morse-Bauer spectroscopy, which uses this tiny nuclear magnetism to probe and study the local electronic and magnetic environment surrounding the iron atom. Earth's magnetic field and the Van Allen radiation belts are closely related, both playing a critical role in shielding Earth from harmful solar and cosmic radiation with great might. And we sent down iron with its great might, Al-Hadid 57 verse 25. The word, sent down, in the Quranic verse, chapter 57 verse 25, regarding iron alludes to its cosmic origins. Iron, like most elements heavier than hydrogen and helium, originates from stars. Here's a breakdown of its cosmic journey to Earth: stellar furnaces, where iron is forged. Stars are giant cosmic furnaces. They primarily generate energy by fusing lighter elements into heavier ones in their cores. Initially, hydrogen fuses into helium. As stars age and run out of hydrogen fuel in their core, they start fusing helium into carbon, then carbon into oxygen, and so on. This process of fusion continues until elements up to iron are formed. Iron is unique because it has the most stable nucleus of any element. Fusing elements heavier than iron actually consumes energy rather than releasing it. This means that once a star's core is primarily made of iron, nuclear fusion stops providing the outward pressure needed to counteract gravity. Massive stars, much larger than our Sun, go through various stages of fusion, eventually becoming red supergiants with an iron core. Supernova explosions, spreading iron across the universe. When a massive star's iron core can no longer sustain fusion, gravity causes it to rapidly collapse. This collapse is incredibly violent. The sudden collapse leads to a massive explosion called a supernova. During this explosion, immense temperatures and pressures are generated. While iron is the heaviest element formed through standard stellar fusion, the extreme conditions of a supernova allow for the creation of elements heavier than iron through processes like rapid neutron capture, our process. The supernova blasts the newly formed elements, including vast quantities of iron, out into interstellar space. This stardust mixes with existing gas and dust. Formation of our solar system and Earth. Over billions of years, these enriched clouds of gas and dust, including the remnants of exploded stars, coalesce under their own gravity. Our own solar system formed from such a nebula. The swirling cloud flattened into a disk, with the sun forming at the center. Dust and gas particles in the disk collided and stuck together, gradually forming larger and larger bodies, planetesimals, and eventually planets like Earth. Because iron is a relatively heavy element, much of the iron in the early Earth sank towards the center, forming its dense, metallic core. In summary, the iron found on Earth, including the vast amounts in its core and the smaller quantities in its crust, originated from the cores of massive stars that lived and died long before our solar system even existed. We are quite literally, made of stardust. The word great might, in the Quranic verse, chapter 57 verse 25, can be understood in several ways, referring to iron's inherent properties and its crucial roles, the great might of iron, Earth's magnetic field and the Van Allen belts. The Earth's core is primarily composed of iron, with a significant amount of nickel, and smaller percentages of several lighter elements. Because we cannot directly sample the core, its composition is inferred from various geophysical data, like seismic wave velocities and Earth's density, and geochemical models, comparing Earth's composition to meteorites. The provided breakdown shows the Earth's core is composed of approximately 85 to 90% iron by mass, with about 5 to 10% nickel and another 5 to 10% of lighter elements. The Earth's magnetic field is primarily generated by a process called the geodynamo, which occurs in the Earth's outer core. This is a layer of molten iron alloy that surrounds the solid inner core. It's this liquid outer core that is crucial for generating the magnetic field. Without the dynamic processes in the Earth's outer core generating a strong magnetic field, the Van Allen belts would not exist in their current form, and Earth would be much more vulnerable to the harmful radiation from space. The great might of iron, hardening iron. Iron's great might is also evident in its ability to be hardened and strengthened through alloying. For instance, iron can be significantly hardened with manganese. Interestingly, the atomic number of manganese, Mn, is 25, which is the same as the verse number of iron mentioned in Surah Al-Hadid, chapter 57 verse 25. Iron, when alloyed with manganese, to form steel, directly contributes to increased strength, hardness, and wear resistance. While carbon is the primary hardening agent in steel, manganese works in conjunction with carbon to amplify these effects. Hardenability. Manganese is exceptionally effective at increasing the hardenability of steel. Hardenability refers to the depth to which a steel can be hardened by heat treatment, quenching. Manganese achieves this by lowering the critical cooling rate required for the formation of martensite, a hard, brittle phase, and by influencing the transformation kinetics of austenite, the high-temperature phase of steel. This allows for more uniform hardening throughout a thicker section, making the steel stronger and more consistent. Solid solution strengthening. Manganese atoms dissolve within the iron crystal lattice, causing lattice distortion and hindering the movement of dislocations, defects in the crystal structure. This mechanism, known as solid solution strengthening, increases the material's yield strength and tensile strength. Grain refinement. In some cases, manganese can promote finer grain structures in steel, which generally leads to improved strength and toughness. Fun math. The chapter of Al-Hadid contains a total of 2,505 letters. Iron has 4 naturally occurring stable isotopes: iron 54, iron 56, iron 57, and iron 58. Iron 57 is magnetic. This number is connected to the sequence 54565758, which, when its values are combined in a specific way, resolves to that exact total of 2,505, as follows: 545 plus 456 plus 657 plus 758 plus 57 plus 5 plus 4 plus 5 plus 6 plus 5 plus 7